Okay, the hour is late, so it's going to be a late night stream of Odinmade Hero, kicking off day 37, where, what is the topic for today? Basic bitmap rendering. Last night, let me make sure I'm live on YouTube before I go any further. I didn't see that I was live. What is going on? Don't do this to me, YouTube. Oh, there we go. Okay, we're good. So yeah, yesterday we left off trying to get bitmaps to load, bitmap files, and we, I was trying to get the BMP package for Odin to work, and this is what we wound up with, which looks different from Casey's, and this is actually not even using the BMP package, I don't think. Yeah, so what we're doing here is I've left this code in because I didn't know whether I wanted to try and use the BMP package or just try and use the OS package to read in all the bytes from the file and then maybe start parsing it the way that Casey does, or just try and default to Odin's BMP package. I was hoping that using the BMP package would be a little bit more straightforward, but it gives me back this buffer, what is it, bytes buffer? Or the pixel buffer? Yeah, bytes.buffer. So I was spending some time earlier today just kind of looking at this and trying to figure out what I want to do. And I did try to go Casey's route. I just wanted to play out both scenarios because on the one hand, I don't want to stray too far off of what Casey's doing and make it harder on myself to kind of reconverge where the code needs to go, the direction the code needs to go in, because I'm doing things too differently. So I tried doing things this way. I actually tried sticking with this because we were getting some weird output from using the BMP package. What I tried doing is I looked in here and I found that this image struct in Odin's core image package. So we have this bytes.buffer thing, but we also have, you know, the metadata associated with the image that we're trying to read. That one is right down here. It's this union where if we're trying to read in a BMP, we get all of this stuff here that is helpful. And it's kind of what Casey does at the end of the previous day, where he takes that read result and then he casts it to the Win32 file struct. I can't remember what the name of it is, but it gives him, he's able to get basically the header out of the BMP file and then start figuring out like where the bitmap offset is, right? And I tried just straight up casting the bytes out of this load here, taking this data and just straight up casting it to that that type. What was it? It was like image.bitmap info or something. Something like this. What was that called again? Why isn't it coming up for me? Do I not have that package? That's right, I think I stashed everything, and that was including this import. So inside of this package, I can pull out, yeah, there it is, BMP header. I was trying to do something like this, and then using the header, I could then dig into the bitmap, you know, the actual image that we're trying to get loaded into our pixel buffer, starting at the correct offset. And that didn't work, and I'm not sure why. And I tried digging into the BMP package code to figure out how that's being done. Load from bytes goes into load from context, and then down here is where that header gets pulled out. And it looks a little bit more complicated than what I was trying to do, but it looks like they're generally doing the same thing here. But then, you know, there's this read slice call, and then that goes into this procedure group where we're calling read slice from memory. There's all this stuff going on that I was like, you know what, I should just try my best to get, you know, the BMP package to do what I needed to do. So I kind of backed off that idea and decided that I'm just going to try and do as much as I can using the BMP package. Now, I think that'll work out fine. If it doesn't, then I can spend some time figuring it out. But obviously, trying to go this way, you know, I had a problem where I was like, why in the world are we getting that weird... I think if I think I can actually show it here. We're getting this very strange output if we use the BMP. In fact, it won't even work right now. I think because we go down here, for whatever reason, we're trying to read data out of the pixels that we're pulling out of there. That is, like, we don't have permission to touch that. I don't really get it because we're within the bounds. But if I start to kind of hack away, yeah, you see we get this really weird output. So I started digging into that and trying to figure that out. And that's, let me go ahead and get my stash back. Did that work? I did not do that right. I want to reload the file. So if we go back down here. So what I discovered is that we weren't getting an alpha channel out of the bitmap when we call load from file. And there are some options in here that you can pass that I was trying to intuit how it works if we dig in. I was hoping I could just pass it in, you know, as an option, and then it would then add that alpha channel. Because basically what is happening is I was getting the image back, but each pixel was just 24 bits, right? There's no alpha. So that wasn't fun. Yeah, we're doing a slightly late night stream here. It's going to be a short one too, because I don't want to be up super late with code on the brain. Not that that doesn't happen anyways, but it's that much worse when I'm like at the desk looking at monitors. So anyway, you know, I tried passing that in as an option for some reason. I mean, it compiles just fine when I do that, but I just have a hunch that I am doing this incorrectly. Right? Like this should be setting a bit in the options that would then load in the alpha. But it just does not seem to, for whatever reason. And I think if I comment this out, oh, now I have, oh, I'll just comment that out for the moment. So I do this, I think it'll blow up. Yeah. So it tries to iterate, you know, over the pixels and read them into the frame buffer, or write them into the frame buffer, I guess I should say, but it doesn't work. So what I did was just call that proc directly, and now we get an alpha channel added to our bitmap. The other thing that I was talking about doing was changing the return value of this proc to just be a slice of pixels, essentially, U32 slice of colors that we could then write in. And so leaving it off here, I felt pretty comfortable with where I was at. We could take this forward, and I think, you know, we should be just fine doing what Casey does this way, unless it still doesn't work. What did I do wrong here? I thought I had this working, but I guess not. If I go down here, did I not save it? There we go. So, I mean, this is still not what I want to be doing, but this looks closer to what Casey's problem was, and it gives me the benefit of what I want, which is I have the header off of the bitmap. In fact, I don't even know if I need the header because I have all of this stuff off of the image we get back itself. We have the width, we have the height, but if I needed to, I could get into that metadata and we could start using that stuff. In fact, I think I used it to inspect that the color layout is different. It's using sRGB instead of, in fact, I can just throw a print statement out here and we can find out for ourselves. See if I can do this right. It's a bit strange, but I have to call this union, right? It's a union, union, I'm pretty sure. This took me right to where I wanted to go. What's going on here? I want to look at the metadata member. So image metadata is a union. I'm not exactly sure what the shared nil directive is doing, but the point is it's going to be one of these types of images, right? And we have a BMP, and so we look at the header, and just accessing that was weird. Like I was hoping I could just do this, right? Like I just wanted to call metadata.info whatever, but I had to do this. I hadn't seen this syntax before, so that was just something new. And my language server was not, you know, giving me the members of the metadata. But anyway, I think it's just color space is the thing I want to print out. Maybe not. What is it? Oh, why is it PNG info? I wanted BMP info. Yeah, it is just color space. I think I needed to call info on my bitmap info. And then that should print out, yeah, so sRGB. And I'm thinking that what Casey is getting back is, you know, a Windows color space, which now that I mention it, that's what I wanted to look at. Yeah, Windows color space, sRGB, and then just Windows. Windows is special enough that it's got its own color space name. So a lot of this stuff is just kind of over my head. I knew I needed to kind of work ahead a little bit and figure out what I was going to do here because I'm not making those same calls that Casey is. I mean, he's calling that, what is it, debug read file and getting the result off of that to pull out, casting the result from the raw bytes to the Win32 struct, but I can't do that. So I had to kind of think outside the box and figure out how I was going to do this. And this might not be, and probably isn't the best way to go about doing this, but it gets me to where I need to be, which is pretty close to what he's doing. So I think I can just rip this stuff out now and commit to this path. And, you know, if it blows up in my face, it blows up in my face. But that's enough of that. I'm just going to complain that I'm not using my OS import, whatever. Just make sure I'm compiling and running again before I take off here. So let's see what happens. I did skim a little bit. This should be, thankfully, a bit of an easier day for me because a lot of it is just Casey explaining BMP stuff. What does underscore equal data mean? So that is basically saying, let's say, well, first of all, I have compiler switches that basically say, you know, vet unused variables, meaning don't let unused variables sit around, and don't let the program compile if we have unused variables sitting around. But I work around that when I'm just, you know, playing with different stuff. I was making all sorts of changes trying to figure out what the heck I'm going to do. And so sometimes I was getting the pixels off of my bitmap that I get back from this load from file call. And sometimes I was getting the pixels out of this read entire file call to the OS package. And so if I was doing that, if I was, you know, working with the bitmap result, you know, that image result that I get from the load from file proc, and I wasn't using this data, I didn't want to have to come back and keep commenting it out. So I can just do this and then, you know, let the compiler know, hey, it's fine. I know that this isn't being used. But this way it reminds you, you know, whether the compiler is barking at you. If the compiler stops barking at you because you threw this down, well, when you see this in the code, you're going to go, what's that about? Then you delete it, and then you might find out that that thing was never being used, just in case you forgot. But I remembered all too well because it was painful trying to figure this out earlier today. Okay, so let's go ahead and jump in and see what happens today.
Fresh one. There's a fresh one right there. Hello, everyone, and welcome to Handmade Hero, day 37. This, of course, is the show where we write a complete game from scratch, no libraries, no engine, so that we can see absolutely everything that happens when you make a game. And it's sort of like the complete soup to nuts process. It's so that you can kind of learn about every last little thing that goes into executing a game. So there's no more mysteries, there's no more, I don't really know what it does down there kind of stuff. We're going in, cleaning out all the cobwebs, going into the basement, if you will, finding out what your creepy grandfather put down there, you know, stashed in the basement, or what weird sort of pickling experiment someone did, and you really don't want to necessarily eat it. You know, so sometimes it's gross, it's true. But there's also kind of this nice sense of knowing what the hell is in your basement. So, without further ado, let's pick up where we left off, because we have some. I actually thought overnight of something very important that I should tell you guys about for people who don't already know about this, and I realized it's the perfect time to do it. So I'm kind of excited about that. But first, I will mention if you have pre-ordered the game and you would like to follow along at home, on handmadehero.org there's this pre-order button. If you click that, you should have got a link in your email. That link should have given you a download. Basically a page you can go to, and there's two downloads there. There's one that's a source zip that's updated every night, and you want to extract basically out of that zip file the source code for day 36, because we're on day 37.
It makes me sad seeing him plug all this stuff, and then he even has the handmadehero.org URL at the bottom there, and you can't even go to that website anymore.
And then you want to, if you haven't already, you're going to want to extract the, there's basically an asset zip as well that we're working with now. You want to extract that asset zip out into the data directory. So I'll show you where that stuff is in a second. So that is for folks following along at home. I am going to go ahead and jump right in here and talk about the thing that I want to talk about. So I'll say where we left off and why I think it's important to talk about the thing that I want to talk about. All right. So if we go ahead in here, I made this little debug BMP loader, right? Where basically we were trying.
And just to hammer home what I was mentioning a few minutes ago, you can see in this line here, since I can point it out with my mouse, you know, he gets the header out by casting it to this bitmap header type, and this is just straight out of Win32. And you know, it could very well have something to do with this pragma pack push and pop stuff. Maybe that's what I was missing and why I can't cast. But you know, it was just a weird thing. It was a weird rabbit hole to start going down because I'm dealing with Odin's type, you know, so I didn't care to waste too much more time on that. And besides, I'm not going to be able to build a better BMP parser than the Odin contributors anyway, so just figured I would take the path of least resistance wherever I can.
Trying to load in a bitmap file that we stored on the drive. Now, like I said, basically what we have here is in our directory is we have code and MISC, which is what we've been working with before. All the code goes in here. MISC is just kind of a place where miscellaneous stuff ends up, stuff like the Emac config. But now we've got a data directory. And inside that data directory, I gave you that assets zip that you can download, and it's got this sort of test thing in here, which has a bunch of stuff. And we wanted to load this file, right, which is a background. It's basically like an image, right, that we need to load. And so what I did was I loaded this file in, right, test background.bmp. And then what I did is I said, well, okay, you know, we wrote the code to just load it in. It's pretty simple. We read the file in, we look at the header was correct, and then we used the offset that was in the header to get at the pixels. But we really didn't do anything more than that. And at the very end of the stream, I kind of said, well, we could just dump the pixels straight out to memory and see what they look like. And I did that, and of course, it looked like this, which is partially not surprising because there's a bunch of things that I didn't actually do in the thing that dumps. It's literally just dumping them out, so you wouldn't expect them to look right even if they weren't busted. But what I realized is rather than debugging this, what I should show you, because I think,
and I feel better about, I was really not feeling good about using the BMP package when I saw that we were kind of getting the image, but it was gray. And again, that was because I was missing this alpha add if missing call here. I would like to not have to make this call here. I would like to be able to just, you know, say, hey, if there's no alpha channel in the file I'm trying to load, just put one in there. And, you know, that was kind of a pain to figure that out. But once I did, I was looking at it and I realized it only had 3 channels and we need a 4th one for the alpha. Then I was getting a result from using the BMP package that looked closer to what Casey's getting. And so that just feels like a better place to start off from.
I think I could probably debug this straight away. I've done enough loading of art files and stuff in the past that it probably would be pretty easy for me to go ahead and debug this by intuition. What I'd rather do is show you sort of the proper low-level basic way to debug something like this starting from scratch. And actually, it involves another step that you are going to have to do. And I need everyone who doesn't already know how to do this sort of stuff to actually trust me and believe that this is something you want to be able to do. So what I want you to do is you want you to find a paint package that you're comfortable with if you don't already have one. So for example, I usually use GIMP. We've been trying out Kita on the stream. That one seems pretty good as well. But usually I use GIMP, and you can get that for any platform. And so what I want you to do is I want you to find a paint program that you're comfortable with, that is reasonably, that works reasonably well and can save, a variety of file formats and whatever. And what we are going to do is we are going to make a piece of what's called structured art. It's basically an art file that is designed to make it easy for us to debug it, right? So what I'm going to do is I'm going to make a file. I'm going to make one that's pretty tiny, for starters, right? I'm going to make one, let's say, I'm just picking these numbers totally randomly. I'm going to make one that's 60 pixels by 40 pixels, okay? That seems totally reasonable to me. So here is my 60 pixel by 40 pixel bitmap, right? Then what I want to do is I want to kind of come in here, and I want to make this guy, I want to make something where I'm going to be able to put a pattern into it, such that when I load it into our program, I know what I should be seeing everywhere. I know what the values should be, right? So what you have to do in GIMP, you need to add an alpha channel if you just have one by default in order to get something that actually has alpha like this, right? Which is what I actually wanted. So this is actually, this has a 0 in the alpha channel everywhere, right? And so now what I want to do is I want to kind of go in there and I want to put in something that I can easily understand. So I'm going to use the pencil tool and I'm going to go ahead and set that size down to like 1 pixel. It's kind of awful, GIMP is at editing pixels. So like, for stuff like this, you'd arguably be better served with something else. But it's something I know how to use, so I'm going to use it. So what I'm going to do, just as a very simple example of what I'm talking about, is I'm going to go ahead and make 1 red pixel, right, at the beginning. Okay, I'm going to go down here to the last row, and I'm going to make a blue pixel, right? And again, I'm actually making something that's literally 25500. So I'm going to go in here and make something that's like the other thing, 2550025. I'm going to put that right there, right? And then I'm going to go ahead and say, all right, at the very end of the row, I'm going to put a green in both cases, right? So I'm going to go ahead and say, all right, let's go 0, 255, 0, right? So I'm going to put that green. I'm going to put a green right there, and I'm going to put a green right here. There we go. So there I've got my sort of pixels in known locations. And then I'm going to also furthermore do something where I get that second row. The second row I'm going to set to be yellow. Okay, right there. And I think that's about it for now. So this is my bitmap, right? Now you may ask why on earth I'm doing this, but the answer is because, well, the things that are going to go wrong when I actually do this. Oh, you know what? I should do one more thing. I think actually I should do one more thing. I'm going to set the next pixel basically to be, let's say, maybe white. I'll set the next pixel to be white, so everything's set. So the next pixel will be white on that one and on this one. So basically what I've done here is I've put colors in very...
I gotta stop doing that. I gotta stop leaving myself muted. All I was saying is that thankfully I already did the structured art thing here. And it was really tedious, but it was really eye-opening when he showed how useful this is when you know what color values to expect, and then you can see exactly what's going wrong if something is going wrong. And it makes it easier to move forward and debug the thing.
Specific strategic locations so that I could see, so that I would know when we look at the actual binary that we load in, I would be able to see where things are. I think I'm also going to cap with black potentially, just as one further thing, just so I can kind of make sure that there's zeros next to these guys, if that makes sense. Something like that. Yeah, looks a little better. And so now what I'm going to do is I'm going to export this. I'm going to export this as a special test bitmap that we can use to essentially calibrate our loading code, if that makes sense. So this is structured art.bmp, let's say, and when it comes up with all of these options, what I want to do is say, all right, I want it to be in the 32-bit ARGB format, which is what I tried to save the other guys in. And of course, maybe maybe I didn't quite do it right, but that's the format that I want to save in. So 32-bit ARGB, which is what I thought we were using. I'm going to go ahead and export that, like so. And now we have a bitmap whose structure I know exactly, right? So I'm going to come in here now, and I'm going to go ahead and I'm going to look at that bitmap in the loader and see if I can verify that we are loading things properly, right? So it's that structured art. Instead of going in there, it's structured art.bitmap, right? That's what it's going to be. And I am going to step in here, like so. And now after we read the entire file, again, we're reading structured art.bmp. We look at the header, and the header should tell us the things that we thought it should be, such as the width and the height, and it does look like that's actually the case. So that's all good. And then we have sort of this bitmap offset that's supposed to be where the actual pixels start, and so we're using that here to offset ourselves to that location. And so now what I should be able to do is look at the actual pixels themselves.
Oh no! I don't know how worried I should be about this. I mean, clearly it's because we're outside of the bounds. I think he disabled that code, actually, now that I think about it. But if we go back in here and we throw in a print, now what was he inspecting? Just the actual pixels coming back out of the structured art, quote unquote. So we have our bitmap, and then, well, he's just looking at the pixels, so maybe I should just print the pixels once we've gotten them out of the buffer. How about we print out the first pixel instead of all of them? Because I just realized I think like the rest of it is transparent, right? And that's not really what do I want to do here? I could pull can I get like, I think this is what I want to do. Let's get the first pixel out, but as a U8, right? What are you talking about? What is this error? Pixel declared but not used. Okay, that's fine. Cannot transmute 4 versus 16 bytes. Yeah, because a U32 is 4 bytes. Well, I think this is what I meant to do, right? No? I feel like a crazy person. Shouldn't the first pixel be a single U32 and therefore be, give me 4 U8s out? For some reason this is not computing, but you know what? I'll just do this, and I think that'll give me like the first pixel out. I guess I meant to go to the 4th. Actually, I guess I don't know what order this is going in. So if this is sRGB, I'm thinking that last 255 is the alpha, and that first one is red. If I look at that art, is that, that's not what I wanted to look at. I go into data, look at structured art. And I guess I could have just rewound the video. But yeah, that first pixel is red. So I think we're on track. What about the second pixel? This will just be white, right? So I think it'll all be 255. Yep. And then the next one was black. So I guess by adding the alpha channel, it just fills it all with 255, which I suppose makes sense, right? Because that means if there's no alpha channel in the original art or the original asset, whatever, then everything is just set to max opacity or min opacity. What would that be? It's completely opaque, so it's max opacity. So that makes sense. And this was my hunch too, because my hunch was that you know, this call was giving us a bitmap like in order, like the first pixel corresponds to the top left. When we saw printing out without the alpha channel, even though it was all bugged to hell, we saw the trees. Well, actually, I guess you couldn't really tell, could you? Yeah, no, because the trees were pointing up. So this makes sense. We're good to go.
And I should actually now be able to see structured values that tell me what I am actually looking at, right? So if I look at these pixels and I'm going to go ahead and say, let's look at the first row that comes in, right? And I'm going to go ahead and say that I knew the thing was supposed to be 60 wide. In fact, you know what? I'll look a little bit further than 60. Let's look at like 64, so we can see a little bit over the edge of that first row. And so now if I look at this, what do I see, right? Well, I see that there's that FF on the low that's filled 3 pixels in, right? And then I see a bunch of stuff that looks kind of, I don't know, that looks sort of like it's almost, if we were to read this in little endian format, basically, this would actually be, we would expect that to be the red, that to be the green, that to be the blue, and this to be the alpha, right? But if this were in big endian format, again, we would expect it to be the opposite, right? So we would expect it to go, okay, the top part would be the alpha, and then, sorry, the bottom part would be the alpha, so it'd be RGBA, right? Looking like that. So looking at all of these zeros here, it pretty much tells me that either we're off by a little bit, or these are getting read in not the same color order as we think of them, right? Because when we were thinking of them, this was A, this was R, this was G, this was B. And it's pretty clear that our bitmap, when we made it, was not at all, like most of the values in it should have a 0 alpha. And so that 0 is clearly our alpha. And so why the alpha is ending up there is a very good question, right? And something that we need to think about. So let's think about this a little bit more. If I go in here and I look at my 2 rows that I've got a blue, a white, and a black, and I've got a red, a white, and a black. Now, it occurs to me after I'm looking at it here, since we don't know which order red and blue go in, I probably should have swapped these, right? What I probably should have done, and I guess I could do that right now, is use something unambiguous like green, which will show up in the middle channel, right? That'd be an easier way for me to sort of bullseye exactly what order my stuff is coming in at. Because I don't know whether the bottom row stored first or whether the top row stored first. I mean, I kind of probably do because I think I remember stuff about the bitmap format, but again, if you were coming at this completely fresh, you wouldn't know. It could be stored from the bottom up, it could be stored from the top down. Heck, it could even be stored like columnar for all we know. So we want our structured art to have enough information in it that we can literally figure out basically anything that we might need to know just by looking at what comes out in the structured art, if that makes sense. So I'm going to change around what we did there. There we go. Okay, blue, blue, and then I'm going to go ahead and export that. So now I expect to see red is at the top, green is at the bottom. So whether I see something that looks like a blue or whether I see something that looks like a red, I know that I'm looking at that, unless they started this way and went that way, which I've never seen before in an entire thing. But even if that happened, I would know because there wouldn't be a white in between. So I would see that the black came immediately afterwards. All right, so I'm going to step back in here, going to go down here again, take a look at that pixel pointer. So there's our green, right? We know that's pretty much unambiguously going to be green because there's no way pretty much that if this is, we know this is the alpha at this point, so we kind of now know that that's the green channel because there's nobody's in the history of time, as far as I know, ever stored red or blue in the middle. It's always green that ends up in the middle. So that means we're looking at this row. So basically we're bottom up, we're storing the bottom row first, and we're going upwards, right? And we now know the format. The format is that the first thing is the alpha channel, the first byte, because you can remember we could also look at this in byte order if we wanted to, so we can ignore endianness for a moment and just look at it in byte order, right? Here's that first pixel. So we now know that like the first byte is an alpha value, the second byte is either red or blue, we don't know. The next one is green, and then the next one is whatever this one wasn't, right? So it's A something G something is the byte order, right? So I can basically say right now that I've determined that rather unequivocally, right? Note, Casey, byte order in memory is it's AA something something, GG something something. So all I need to know now is which one of these is green and which one of these is blue. Well, that shouldn't be too hard because here's my white, here's my black, here's my my sort of alpha pixels, right? But when I get to the end of the row, if I go 64 of these out, right? So I get 64 of these out, I will see right here when I get there, I can show you this in more human readable form in terms of it, right? So I get 60 out is the end, right? So this was the last pixel in the row, was number 59. And I don't know if will this reset it? Of course it does. Thanks. That's so helpful. Thank you, Visual Studio, for God, unbelievable. Anyway, so basically, here's my alpha pixels that have nothing in them, and then I see the black value, which is what I expect to see, right? And again, I guess I know now that I'm on this row, so I'm not wondering which row I'm on this row. And so now I expect to see a blue, and that's blue. So now what I know is the order goes alpha first, right? Then blue, then green, then red, is I guess what we're basically saying is happening here, right? So again, if we look at that, we've got to multiply this out a little bit more if I want to look at it in byte order. But in byte order in memory, it looks rather unequivocally like we are seeing, again, alpha values come first, and then, like I said, when we kind of come down here and take a look at it again, so I can be sure of what we are looking at. It's always hard when you are off pixels. So there's the alpha, something, 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 alpha, something, 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 alpha, something, something, something. Now we have alpha, the color, something, something, right? And so since we expect that to be blue, that means that blue comes first, right? So I believe that this is our order in memory. And again, pretty much determine that strictly from the structured art, right? I determined both, and let's...
Now, I don't actually know if that's Windows color spacing or whatever, or the Windows, you know, the format that like an image defaults to if it's being read in on Windows. I don't know. I'm surely articulating that incorrectly, but the thing that, you know, I really care about and that I want to make a note to myself about is, you know, when we load, I'll put this up here where we load the BMP. When we load the BMP, are we able to specify color spacing, or is this, and I think this is the case. I think it is embedded in the file itself. But I don't know what to make of that because I followed doing things the way he did them exactly when making the structured art. So like, is this call doing something underneath the hood to give it to me? I mean, we already know it's putting the order correctly, where the top, you know, leftmost pixel that we would be looking at on the screen, if we just read it out from the first pixel, it's right where we really want it to be, whereas Casey has to you know, do some work here to get it to order properly, or at least when he writes it out, he's gonna have to keep that in mind, right? Actually, I don't know, is that true? Well, we'll just keep watching and we'll find out.
See, bottom up. So basically we also know that we start with that bottom row first.
I guess I wanted to point out specifically, will it always default to sRGB when we call bmp.load from file? Or is the layout embedded in the file itself? Should be easy enough to figure that out for myself on my own time.
So again, that is without really knowing anything about...
And, you know, it makes more sense that way because, I mean, he specifies ARGB, but then, again, when he's looking at it here, he's got this note about it being in ABGR, or RGBA, I guess, would be the way to read that. Right? Basically, our alpha is in the beginning where his is at the end, I think.
And let's see, bottom up. So basically we also know that we start with that bottom row first. So again, that is without really knowing anything about that.
Yeah, and he does start with the bottom row first, which is just weird, again, because I made the file the same exact way he does, so I can only assume that the BMP package is doing something with it to make it so that the bottom row actually reads out from the top. And that's like a nice thing for it to do if that's what it's doing for us, so we don't have to do it ourselves.
The bitmap file format, that was basically a way that I could reverse engineer how the data is stored using this sort of trick. Now, in the case of bitmap, we could just have read on the internet what the format was, so it's not so important to be able to do this, perhaps. But two things are kind of nice about this. One, it definitely aids in debugging, because if your bitmap loader is broken, even though you know the format, you may still have written buggy code, right? And finding that buggy code is way easier when you know what you're looking at in sort of the variables and in the memory. When you know that the first pixel should be green or the first pixel should be red, it's much easier to verify that it actually was. Whereas if you're just loading some bitmap that an artist made, who knows what the first pixels should be? It's really hard to tell, and you have to keep like looking back and using like the eyedropper, and you hope that that pixel doesn't exist somewhere else that could be duplicated, you know, whatever. So
and to his point, when I was trying to figure this out earlier, like when I realized I didn't have an alpha channel, I was like, why are there 3 channels? And I was looking inside of that call to basically generate the BMP, and also there was another file, or not another file, another proc called, what was it, save to buffer or something, and it would write out the image that you had to handle to out to another bytes.buffer, and I could see, it'll switch on whether you have 3 or 4 channels, and I wouldn't have had the confidence to just go and chase that down and figure out that I was missing an alpha channel, if not for, what he's pointing out right now.
There's that. There's also the case that when you are a game developer, you will also find yourself oftentimes dealing with file formats that are just plain not documented or not documented very well. And being able to do these kind of structured art techniques, if you do have access to the art tool that creates the art, can be really handy, because you can push structured stuff through, see what comes out on the other end, and that's basically a little bit of black box engineering you can do to figure out the stuff that wasn't documented. So there you go. So now we kind of know what we're dealing with here. We know we're dealing with a byte order that's A, B, G, R. And so what we want to do is that's actually not very good for our purposes, because remember, when that actually gets loaded in, so in little endian, right, when that gets loaded in, we basically have a thing that's going to put, it's going to essentially reverse this if you actually think about it. If the A comes first, then the B, then the G, then the R, then what we're going to have is that AA is going to get loaded in first, then the BB, right, then the GG, then the RR, right? Now what's kind of weird about that is that that's almost what we want. That's almost what we wanted, but we have our A stored at the top instead of the bottom. Right? Do you know what I'm saying? It's just a little bit weird. It's like, it's close, it's just no cigar. Like, if we are expecting it to look like that, but it sure looks like from the data that it actually, it's shifted like that. So what we need to do is kind of shift it down and move the alpha back to the top.
Okay, so I think I got it backwards. I think I said that the R was at the bottom, it's at the top. I don't know. It's been a while since I've taken that CS class, so I got my perspectives wrong.
Right? That's what we would need to do to make this thing correct. And so I can actually write a loop to do that, and then it would be in the same format that our pixels were actually in, right? Like I could do something where I just do this, right? I could do something where I do loop through all of these sorts of things here. So I go, header width or whatever, plus y, and then I do, for uint32, x equals 0, x is less than header height, plus x, and then inside here, I basically take the pixel, so
Okay, we'll get to that in a moment, but I wanted to write out that, so this is what his is turning out to, the order, the color spacing, whatever you want to call it. He never calls it color spacing. I'm just going off of what I read inside of the Odin code base. But ours is actually a bit different here, right? We do have the A up front. Is that what he wrote, really? Yeah, AA, BB, GG, RR. So I think ours is already where we want it to be. Both in the fact that the ordering, we get the top row first, and we have sRGB. So that's reassuring. And it makes sense if I actually build this and let it run. The colors, oh, I forgot that I disabled. Well, yeah, that's right. We switched the argument we were passing, because now we're trying to load the structured art instead of the test background. But when we were loading it, it looked like it was green or whatever instead of that blue color. So good news so far.
Have a
That's right. He started working on this code here to start playing with the pixels. So I already have these pixels as a U32 slice, so I think we're good there. So we can just start writing for Y, and we don't have a header, but we have the bitmap width. It's weird that he's specifying the width with Y. I feel like that's a typo. We'll see if that bites me. And is that all he's done so far?
pointer to the pixel. And each time through, I'm going to basically say that source dest equals source dest, and I'm going to just kind of shuffle it around a little bit. And then I'm going to move source dest forward. So basically, source dest is going to equal to basically the shuffle here. I need to shift it down by 8 so that I line up the RG and the B where they're normally supposed to be, but then I need to OR it with itself, shift it up 24 to basically get that alpha up in the top, right? So I just got to basically rotate that around. And I believe that will give me something that's a little bit closer to what I would have been expecting, right? That's kind of, that's going to be laid out in byte order a little bit better than what I thought. Now, of course,
So I'm just going to assume that I do not have to do that. But I don't want to delete this, so let's just say for now, so he gets a pointer. I guess I should let him finish. Where's he going with this?
don't actually remember what these were called in the header. Let's see. Sign oh, right. These are signed in the header. And I'm going to put a little to-do in here because I happen to note this, but I'm going to say, or I'll just put a note. Note, Casey, if you are using this generically for some reason, please remember that BMP files can go in either direction, and the height will be negative for top-down. So basically, that's just something I know about the bitmap file format. Also, there can be compression, etc., etc. Don't think this is complete BMP loading code, because it isn't. Something like
Again, to his point. So I mean, I know that the BMP package is unfinished. Like, I don't know if PNG, I think PNG actually was just added in there recently, but if I jump in here, there's like some to-dos scattered around here in various places. Like if I go in here, well, let's just look for a to-do. Add a strict option to catch non-issues that violate spec. Well, that's great when random files don't accommodate the spec or don't stick to the spec. Handle RGBA, and that's what Casey has, right? Yeah, RGBA. So there's definitely some stuff in here scattered around, but anyway, at the very least, we already do have something that's a little bit more fleshed out than what he has, because again, we're not doing it all completely from scratch.
that. Just in case anyone thinks this is a BMP loader, it's really not. It's just something to load our assets temporarily. So, but ignoring that, I've basically done the little shuffle that I think is necessary, so I'm going to go ahead and take a look and see if basically that...
There it is. There's the pointer arithmetic. So if I make a pixel index, and I've done these enough times to where I better not mess this up. I did that wrong. And then we just say pixel at pixel index equals whatever. I guess we could just assign it to itself for now. Pixels, not pixel. There you go. Will it break? No, we're good. In fact, I haven't even checked to see if the game still does what it's supposed to do. It looks okay. All right.
That produces color values that are more in line with what I expected to see, instead of what we were actually getting. And so here's our source dest pointer, basically, which we are kind of modifying in place. Again, I believe this pixel right here is this one down at the bottom, right? And so what I want that thing to do is I want to have R, G, and B. I want to actually move the alpha from the bottom to the top, right? So what I should see afterwards is basically that, yes, which is what I got. So that will do the shuffle for us there, but we still have another problem. Our other problem is basically that we're basically bottom up instead of top down. And so I guess I don't really know what I want to do about that one way or the other. We could just say that our art works that way because there really isn't any reason not to have it happen like that. So I don't know what I want to say about that. Maybe we'll just go ahead and leave that, but we could also invert it here if we wanted to go the other direction, right? That's something we could decide to do. But for now, we're just going to leave that. All right, and so now if I actually run this, I don't remember, what's our code down here that we were just using to test to put things on the screen? I don't remember. Okay, so basically what this is now, this code actually needs to kind of know the size of the thing that it's actually going to be copying if we actually want to start trying to copy things correctly. So one thing that we are going to have to do is we're going to have to store some information about this pixel pointer that we had here. So we're going to have to make, pixel width and a pixel height. And when we load the thing, we're essentially going to have to fill out all those values. Now, one thing that you'll notice is that well, I guess you know what I could do, though. I guess I could hold off on that a second. I can just say that since we know what those are, I'll just just go ahead and hard code them in for now. But obviously in a couple seconds here, we're going to have to make that real because we're going to be loading arbitrary bitmaps and we can't hard code things. So 60 by 40. So basically we know we have to copy 40 rows and we know we have to copy 60 columns. So there we go. And when we copy this out, what we need to do now is we need to make sure that when we're copying the source and the dest here, that we're actually copying from the right places, right? And so I guess I could also do it this way. I could say I could put the pixel width that we're copying in here. We're copying it like that, and let's see, there we go. I might make those signed for now. There we go. And so this is pixel height, and this is pixel width, like that. And then what I'm going to do here is the destination, right? I need to advance that every time. I'm not going by, this is not going to fill the screen, right? This bitmap is too small. So what I need to do here is I need to actually go ahead and in the dest, I need to sort of turn this into the format we were using before, where we basically have a dest row, right? And if I remember correctly, inside our buffer, we actually sort of, inside our buffer code, we actually had the stride that we actually wanted to use, right? If you remember, we had this, our pixel pitch. So really, I'm going to go ahead and say that we've got sort of a dest row pointer. And at the end here, every time we do dest row plus equals that buffer pitch, right? Like this. So we advance. And then here is where we actually do our dest by taking where the actual row is. And again, that's because we're not actually filling a whole row here. So we need to actually use that pitch to advance to the next row. And we don't want to have the offset that we happen to get. We don't want to use this like pixel pitch. We've moved pixel pitch forward. And we don't want to start from there on the next row. We want to start back at the beginning. All right, so basically we're going to do that. We're going to copy out of the source, and this should be, I guess, basically upside down now because we haven't done anything about that. We're copying into the other buffer right side up, and there you can kind of see that we're sort of starting to get that bitmap there. That looks a little bit more correct. It looks a little bit more like what we would expect to see. I'm going to go ahead and, excuse me, do one more thing here, which is that the amount that we're going to copy.
Well, I guess I'll go ahead and make sure that I can do that. So, pixel width. Oh man, my hair is just going everywhere. It's the end of the day, and I'm falling apart. It's been a long week. A longer month. So I don't want to do any of this pointer arithmetic, so how else should I do it? He's advancing the destination row that we want to be on by the pitch every time. So what if I had like a source index for the pixel, right? We did it that way, and we also had a destination index for the actual frame buffer, the place in the frame buffer where we're writing to. Kind of the same thing, right? But we'll advance by the frame buffer pitch plus x. Is that right? We'll see. Not looking right. We have our structured art, but we are advancing too much. So what's the deal there? Pixel height, pixel width. He's casting. Oh, I see. We're advancing. Yeah, okay, that makes perfect sense. So our destination, the frame buffer memory that we're writing to is in a U32 slice, but the thing that he's using to advance the row is in bytes, right? Because the pitch is in bytes. So we need to get it to pixels. And I think we just need bytes per pixel. The pitch divided by the bytes per pixel. There we go. And I guess I can't really see, but what is going on with screenshot here? There we go. Oh, thanks, Windows. Thanks for letting me know that I took a screenshot, as if I didn't know what I was doing. Why can't I click on this? Why are you like this? I just want to look at my screenshot. Where did that screenshot go? I see red. I see red, white, and black. I can't... Let me just toggle. Yeah. How do I show this on stream? That is not the right thing. There we go. Can I, like, load a picture in my browser? Is that not a thing? Oh, but I can't. Well, can I just zoom? That's as much as we can zoom. Kind of hard to tell, but that sure looks correct, right? We got green in the bottom left, right in the top left. We got our white pixel and then our black pixel. Winner, winner.
This row thing, we kind of want to be able to do this on both sides, right? We kind of want to be able to copy regardless of which one's bigger. So if the source, right, if the source row was, if the thing we're copying from happens to itself be larger than the screen, we want to be able to handle that as well. Whereas right now we wouldn't, because we just keep on copying right off and wrap around to the other side of the screen, right? So what we want to do here is basically say, okay, we're going to use that we have the pixel width and the pixel height, but we need one more thing, basically, which we'll call like the blit width and the blit height, right? We need how much we're actually going to copy, and we're going to assume that those are the pixel width and the pixel height for now, right? But in the case where the blit height is actually bigger than the screen. If the width or height are bigger than the screen, then we're going to use the screen size. So we're basically clipping the amount that we're copying to the size of the screen so that we never overflow the screen size, right? We're just, because that would be bad. We'd overwrite memory or other bad things. Okay, so there we go. So that's just a simple thing to guard against that. I've got my pixel width and pixel height here. We're going to have to load those from a file, but first I wanted to do this part, where basically we go ahead and we get the source row, and we have the test row. Each time we go through, source row also has to be updated, so that's going to update by that pixel width. Again, that moves us from one row to the next row, right? And the other thing we need to do is, since we're copying top down at this point, remember our information, our bitmap is actually stored, excuse me, is actually stored upside down. So what we want to do is we actually want to copy from the top of the bitmap, which is actually the last row, and we actually want to move up each time. So instead of adding pixel width, what we're really doing each time is subtracting pixel width, right? We want to start at the very last row and then move up. So really what we want to do is pre-advance pixel pointer, right, by the pixel width times the pixel height minus 1, right? We want to basically go all the way down to the last row and start there, and that way we'll copy the thing right side up, if that makes sense. Then when we basically go through here, we're going to use that blit height and that blit width.
Thank goodness I do not have to do that.
All right, just to go ahead and copy things out. We do the pixel copy, like so, as they say. Oh, and I got to actually make a source pointer here, right? Source row, like that. Okay, so let's see what we get there. So hopefully that would be right side up now. I wish that I had zoom in, but I don't think I do at the moment. That's unfortunate. But what I can, of course, do is I can select this window and hit Alt Print Screen, and then go over into GIMP. I can then do Paste as New Image, and now I can go ahead and zoom in there and see what it is that I'm looking at. And let's take a look. So there's our image. This is what we expect. This is what we got, and hey, it's exactly right. So everyone's happy. There is joy in Mudville, and structured art has saved the day. Now, if we go ahead and flip back here and say, well, okay, let's try loading something a little fancier here. Let's go back to our other bitmap and see if we fare as well, because maybe we won't. So let's take a look at, I forget what that was called, in the handmade, handmade test data test. It's called testbackground.bmp. So basically, no, I guess that's fine. All right, anyway, so we're in the data directory, and we have test background.bmp. So now let's see if that works. Now we need to know, again, we're not actually saving the size, so let's go ahead and set that pixel width to what we know that that thing actually is. I forget where I actually had that. I think it was in the properties dialog. There it is, 1024 by 576, right? So it's 1024 by 576. And of course, we don't know if we did our clipping correctly because our previous bitmap wouldn't have used it, so this may just flat out crash because we didn't really even look to see if that code was correct, but let's take a look. Hey, guess what? It worked. So there we go. There's our bitmap loaded off disk, exactly like we wanted. Of course, now we've essentially overwritten the whole thing with our graphics, which is maybe, with this as basically overwritten.
Did not catch what he set the width to, 1024. And then 576. Moment of truth. Will it blow up? It will blow up. What did I do wrong? We did clamp this stuff correctly. You gonna tell me what I did wrong? It would be too easy if you did. Okay. Well, I guess I should see if, well, I'll just throw in a panic. Do we need to panic? I mean, this has to be where we are failing, right? Because, I mean, everything, well, yeah. Because we didn't change, well, we changed the asset that we're trying to write out. So, what gives? What gives? Just back up and make sure. I guess the actual asset could be upside down. I started running into some weird issues like this where it was like I was again reading from memory. Okay, so we do make it into this loop still, and we get at least past one of these operations, but at which point do we fail? It was acting like I didn't have access to, like, as if the buffer was shorter than the bounds of the slice somehow, and I was reading memory illegally, which I hope is not happening here. I'm not sure why it would be happening. I guess we just print out the index where it fails, and we can see, well, it's got to be inside of these assignments here. 519, 149, so we're getting pretty far into the right before it blows up. Which access is failing? It looks like it's the destination. Because calculating, there's no way that these calculations are failing. So it has to be, I think it's we're accessing outside of the bounds of the frame buffer. That doesn't make sense. Wouldn't it be telling us? What's the last value that we get in there? So we're definitely writing stuff. Oh dear. What have I done? What if I just go like part of the way? Go a quarter. Well, that's the pixel height. I don't know if we even... Okay. Okay. Oh. We're not using the offset. I don't like that I'm not getting a more... Well, do we need... Yeah, we need the offset, don't we? Do we? If I go back into here... No, I don't know why we would need the offset. But something, I like, so maybe this is not coming through on stream, but I can see that we're, well, it looks like we're getting to just beyond the edge. It's really hard to see. But that could just be because we're writing. Yeah, no, I think I'm getting fixated on the wrong thing. Like what I was wondering is if maybe we needed to index into, you know, this pixels buffer a certain amount, but we shouldn't have to do that. The bitmap that we get back from the load from file call should just give us the pixels, you know, starting at the first index. And we proved that when we printed it out. So that's nothing. So the issue's got to be somewhere in the right. He starts at the bottom and works his way up to the top. But yeah, it's got to be. So we start out at the beginning of the frame buffer. Oh, okay, I think I see it. Well, maybe not. Well, yeah, actually, right? Doesn't this need to be like this? Because otherwise, well, no, that shouldn't matter. This is just, what is it? What is that? Is it commutative property? Actually, I don't know. Yeah, it shouldn't matter, should it? I guess I can check to see if that's actually doing anything, making a difference. Well, I need to actually go. Yeah, I mean, it wouldn't be drawing out as correctly as it looks there otherwise. Yeah, so I think that's nothing. God, why is it failing, and why wouldn't it be a bounds error? I wonder if the fact that I'm not using debug or like a less, you know, optimized build. I wonder if I do that, if that helps me with the error. No? I am building using, yeah. That's not doing anything for me. Oh, is this where I get stuck? I mean, I've been stuck, but is this where I call it a night? Because I can't stand to sit here and speculate to myself on stream for another half an hour trying to figure it out. Oh, I did not change this. Yeah, that was the whole reason why we, yeah. So I think because okay, I'm pretty sure this is it. That was the whole reason we added this code. I didn't actually use the blit width and height to make sure that we weren't writing outside of the frame buffer, but I still feel like this should have given me a bounds there. I mean, that's the whole point. I've been, you know, talking about slices nonstop, and that's the whole point. Is that it's supposed to give me a bounds error, out of bounds error, and that wasn't it. Are you serious? Okay, I just didn't save. Well, that's not quite right. But we do have a texture on the screen finally.
Let's go back to our other bitmap and see if we fare as well, because made, oops, they're handmade. So basically, we're the data directory, and we have test. But again, we're not actually saving the size, so let's go ahead and set that pixel width to what we know that that thing actually is. Let's take a look. Hey, guess what? It worked. So there we go. There's our bitmap loaded off there.
Well, my mushrooms are blue, and his are red, and that looks more correct. It looks like we went from Minecraft's main overworld into the Aether, right? Just change the whole palette. But this is still really good, you know, because everything else, other than the colors being wrong, everything else looks good. I can live with that. So I need to go and mess with this. No, this. So the color ordering is wrong, which is weird because it was fine with the structured art, wasn't it? I could have sworn it was. That kind of bothers me. Well, yeah, I don't know what to make of that. Why would it be, why would the color ordering be correct on the one thing and then not on this thing? I guess he did have to change. Yeah, no. Well, let's just see. I'm going to try this again. And, well, yeah. Let's try and get the pixel out of the pixel. Oh, gosh. Yeah, we want one pixel out of the pixels slice. Can I transmute that into a U8? Well, oh, maybe that's what it was. I was trying to transmute the U32 value instead of like taking a slice from this, right? And then if our ordering is sRGB, we can pull it out like this from this first pixel. Well, maybe we just call this bytes. I don't know. Let's just leave it as pixel for now. Pixel index 3 and then 4, right? Because Lord knows that I'm not going to be able to shift the bits around the same way he does it. I guess I could always try, but I don't think that's going to work. What did he even do? He did like, I think it was like this, and then he ORed pixels at pixel index. Well, that's not right either. It seems to me like we just have the blue and green swapped. Yeah, can I just, this is gonna make me comment out everything. Let's just try this for now. Silence that compiler error and look at this again. Our mushrooms are blue. They should be red. These trees look, green like they're supposed to be. The grass has like a bluish hue where it should be yellow. I just feel like blue and green. Oh. And this would make it in the order. Yeah, I don't know. I don't know why that doesn't work then. Isn't that what he did? Have to go back pretty far. That was a while ago. Yeah. So that's what he did. And is it because the color spacing? Well, maybe the color no, because I looked at the color spacing for the asset and it was sRGB. I don't totally understand what's going on here. Clearly, but that's okay. Let's just go ahead and swap those out, right? And see if that fixes it. So we pull out the ARGB, at least I'm pretty sure that's right. And if we wanted to write it back out, we would just do this. This is pretty kooky, but so be it. So it would be RGBA. And that seems laid out the same way his was. Oh, I gotta uncomment this out. Don't need the instantiation there. So we just assign those. Oh, I did not mean to do that. I meant to. Well, hey, that's kind of cool. Now we're, I don't even know, totally another different biome there. We can just play with all the colors. What happens if I do this? We'll just shift some bits around and see what the hell happens. Now we're green. Okay, that's enough of that. I think this just works, right? Nope. Now we're blue. Oh, I totally got these indices wrong. So just take the pixel apart, and that still didn't work. What's going on here? Did I not save it? Did I not write? Come on now. Please. Nope. So we write a, yeah. What am I missing? Maybe this is just wrong. Maybe it's like this, we pull it out. But then this way we'd just be reversing the order, right? Oh. Why am I calling this S? sRGB. Yeah. S and A kind of interchangeable, I guess. Now we're way too green. Okay. I feel like we were closer before. RGB. B, B. This just gives us the same thing. Just trying to sanity check here. That does not give us the same thing. Oh. It's because I messed up the indices over here too. Yeah, that makes sense because that's where I yanked from. Wow, it is way too late to be doing this. Okay, so this will get me right back to where I was when I started, right? Yeah, so we got blue mushrooms, and now if we swap... Well, wait a minute. Is this how it was before? Well, I can just see if this actually fixes it or not. If we swap the blue and the red, I don't think that's saved. Try that again. Swap the blue and the red, and we're way too green. Okay, yeah. So I think this was blah blah blah. This was the original order I had these in, right? Because R is stored at the top, or blue is, I guess. I guess I don't even really need to pull out all of, well, let's just see if this works. So swap the B and the R. Yay, red mushrooms. We did it. Hello, DJ. What am I building? I'm like starting to refer to it as like the Handmade Hero challenge. I'm following Casey Muratori's series here called Handmade Hero, and I'm learning how to build a game from him on stream. And but I'm doing it in Odin, so I'm calling it Odinmade Hero. So yeah, we've just been trying to get these colors to swap correctly, and now they are, but it doesn't seem right to me that they were in the right order for the structured art. And they're in the wrong order here. So I have to go change things around. I guess it could be because we add that alpha channel. Like, where exactly is it adding the alpha channel? I guess that's kind of something that I didn't really think about. If there is no alpha channel in the bitmap that gets loaded, does it get thrown to the end of the pixel value or in the beginning? Does it depend on the color spacing? I feel like we're going to run into problems here down the line, but at least for now, this works. And I think all we really needed to do here was pull out the blue and the red. And so that's byte 0 and 2. Just kind of simplify this a little bit because we don't really need to reassign the green and the alpha channel. This just is easier for me to do. Maybe it's like way less performant, but this is easier for my brain than shifting bits around. It's almost certainly not as fast, but I don't think it really matters.
And then we basically replace these pixel width and pixel heights with basic change this something like this. I don't know what.
That's right. He started adding a bitmap class here. Oh wow, I jumped way ahead actually.
We could go ahead and do that, right? We could go ahead and draw that here. And
oh, I see. He just moved the draw code up above the room drawing code.
There's our bitmap loaded off disk, exactly like we wanted. Of course, now we've essentially overwritten the whole thing with our graphics, which is maybe, with this has basically overwritten our entire tile map graphics, which is probably not the best thing to do. So maybe let's go ahead and move this up to the top. That might be a little bit saner of a thing to do, so that our tile map draws on top of it or something like that. I don't know, just randomly thinking out loud here. Not sure if that's the best thing to do or not, but we could go ahead and do that, right? We could go ahead and draw that here.
So up above where he clears the screen, that's probably not going to work, right?
And then we could do something like only actually draw the rectangle.
Whatever. Let's just go ahead and follow his lead there. So we define all of that up here. And if I build it real quick, make sure that moving the code doesn't break it. Yeah, so we just wipe it all out.
In the case where it was actually also not empty, right? We could do something like this. I think this would work. For example, I don't actually know if it will or not. What did I do wrong there? If tile ID is greater than 1, oh, because we still got this thing in here. Right, so we still got our clear. Let's get rid of our clear. There we go. Much better. And so now we've got our backdrop. There it is. Very nice.
Okay, so he's just going to... I can't do that if 0 stuff, so I guess I can do... I was doing this with Zig. Where we... just say, you know, if it's true, it's basically the same thing, right? If this block is true, then we'll draw our background. Otherwise, we'll clear to red, and then this should work. Almost. I got to change the tile value. Conditional over here. So if there's nothing there, we won't draw anything. Nice. We're still in rectangle land, but at least we have some scenery. Some scenery that just never changes. No matter how far we go, we're stuck where we started off at.
So we now have a backdrop that's just kind of sitting there. Doesn't really do much for us, but we now know that we can load art assets in, and that is pretty handy, right? That is always a good thing to have, and like I said, we're going to need it for almost everything else that we do in the future. We're going to need that. We're also going to need to load some sound in here eventually, but, you know, what are you going to do? All right, so we've got some graphics in there. That's a happy day. Everyone loves it when graphics are in there, but we kind of only have part of the story there because our loader doesn't actually return the information we need. We had to hard code the pixel width and the pixel height. So I think what we want to do now, of course, is we want to go ahead and actually have some way that that can be returned directly, like, you know, something like this, like a loaded bitmap, right? Something like this. I don't know what we're going to call this eventually. Like I said, don't think about it too hard. Just start, you know, basically typing in what first comes to mind. So
I think that I'm just going to call it a bitmap. Where is my world? There is my world. What in the world? Bitmap. Just a couple of ints for width and height.
we can actually return it. So we know we need that width and that height, and then we also know that we need the pixels. Those are the things that we had for our loaded bitmap. And so now what I'm going to do is I'm going to try and just change this code over just in place, like I said, to use one of these. So I know if I had one, it would work. So let's go ahead and say that we have a loaded bitmap here, and this is going to be that backdrop that we had. So we have that somehow. We don't know where we got it from. That's fine. And then we basically replace these pixel width and pixel heights with basically just the backdrop width and the backdrop height, right? Like this. Backdrop width, backdrop height, like that. And similarly, when we come down here, that pixel pointer is not going to be the game's pixel pointer anymore. It's just going to be backdrop arrow pixels. And the same thing's going to happen here with backdrop width and then backdrop height like that, right? So that's all we need to do there.
Easy enough. These are some easy changes. I like some easy changes after screwing around with RGB values and bitmaps and all kinds of stuff. That's just, it's out of, it's far enough outside of my wheelhouse and foreign enough to me that I'm I knew I wasn't going to be able to figure out, you know, I can only imagine how difficult that would have been if I had just jumped in fresh off of yesterday's stream, because that was messed up, that thing that we were writing out to the frame buffer before. It would have probably taken me the entire stream just to figure out that there was no alpha channel. Okay, so the backdrop, he's just Not going to say where it's coming from, but all of the rest of this, yeah, comes off of... Okay, so this goes away, and these come off of the backdrop. Then over here, we have that, and then was there any other places there? Well, I don't have to calculate the, whoops, bumped the mic. I don't have to calculate the final row there because I don't need to do any of this pointer arithmetic, so I think that's it.
I think the rest of it pretty much takes care of itself. Again, this one, just replacing that pixel width there. And let's go ahead and compile that. And then, yes, this is the only thing. Where we get it from, we don't know. Well, we know we want to keep this around, so we'll go ahead and put it in there. There we go. That's our backdrop. And so here we go, loaded bitmap.
Just going to throw it on the state. It's fine with me. What do you mean there's no state? There we go. I think I can get rid of that now. And this will be backdrop. And it's a bitmap.
Backdrop equals game backdrop. There we go. And so now we've actually got it. Of course, if I run this, we will just go ahead and crash because we haven't actually initialized that at all. So basically what we want to do is we want to have our load bitmap return something that we can stuff in there, which implies, again, that our load bitmap structure returns a loaded bitmap, which makes pretty good sense, I would say. So we have loaded bitmap. Oh, and you know what? That's not really a pointer, is it? There we go. So that's going to return a loaded bitmap. That loaded bitmap is going to be the result.
So, oh, this right here too. This is coming off of backdrop. Pixels. I didn't even bother to see what OLS would say about my changes. It wasn't happy. Okay. So now if we go to load DMP or BMP, or we're calling that, this gets assigned to backdrop, and then this now needs to return one of those. And like he's saying, we're going to have a result that is a bitmap, and maybe we'll add some other stuff to it here shortly, but result.pixels is going to be this. And we're not declaring it anymore. We return the result, and as soon as we've loaded the BMP, we can say result.width equals bitmap.width and say the same thing for the height. I think this just works. And it does. Hooray!
There we go. And then when we come down here, when we load up the pixels, our result.pixels will equal pixels, our result.width will equal the header width, and our result.height will equal the header height, like so. And then we just have to kind of, oops, typo there. Got to fix this guy to take the address. So now we are loading in the bitmap in theory. What is the problem? That's game state. There we go. And so now we should be able to load it, and hey, it does exactly the same thing it did before, but now we can load any.
I guess I didn't make that a pointer. I don't know how much it matters that we didn't, but we can go ahead and do that.
Bitmap we want. Now that we can load any bitmap we want, things get pretty easy. If we want to load lots of bitmaps, right, we could just load anything that we wanted to, right? We could go ahead and load just about anything. We could load in here, let's say we load a player. Of course, our player, I don't know if you noticed this, or I should say our hero, is broken up into pieces that have to get assembled, right? Like that. They're the bottom, the middle, and the top, if that makes sense. So we kind of need 3 pieces for our hero, that's true. So I guess what we probably want to do there is go ahead and load 3 pieces of our hero so that we can reassemble him, right? That seems like a pretty sane thing to want to do. So let's go ahead and do that. We'll load player head. We'll load player cape, and we'll load player torso, and we'll just pick one of them. Let's say move it, you know, the forward one. We can go ahead and load that in there. So let's put that up at the top where we actually did our loading, right here. So we're going to go ahead and do player head, that, and this will be, I guess it's not the player really, it's really the hero. You know, I mean, he's a hero after all. Look at him. You can tell he's got bravado. So test hero, there we go, test hero, and I'll load the front one. So test hero front underscore. So basically we need to do 3 of these. So we have.
Hold on there, Jethro. We've got to go ahead and add these in too. Player, no, not player, hero head, torso, cape, right?
Test hero head, test hero cape, test hero torso, and the corresponding bitmap files. So there we go. We've loaded all of those in, and hopefully that will just work. Let's take a look and see if it does. Doot, doot, doot. And game state. Let's see what we got here, people. Doot, doot, doot. Look at that. We've got some very nice hero graphics all loaded in. Everything's kosher. And so if we want to display these on the screen, obviously we could just cut and paste this code that displays the other thing, but really what we'd rather do is just obviously have a utility function that draws a rectangle on the screen. But instead of drawing it the old school way, this time it will actually just go ahead and blit graphics to the screen. So what I want to do is I basically want to copy this stuff out, right, entirely. Just go ahead and eliminate that and replace that with something that's basically like, you know, just go ahead.
Oh no, we worked so hard on that code, man.
Eliminate that and replace that with something that's basically like, you know, blit bitmap or draw bitmap, something like this. And then we pass the game backdrop here and some more information. I don't actually know what it is. And so I basically want this to be bundled up so I can call it multiple times and draw the hero as well. So here we go. Let's go ahead and get that in there. We have.
Okay, so he's just moving it. All right, fine. See if we can wrap this up real quick. If we go up to, where's he dropping that in? Yeah, just above game update and render. I guess we're gonna call this draw bitmap. And there's gonna be a bitmap passed to it. I guess I don't know if I wanted this to be like bit_map or just bitmap. Whatever. If I make that change, I'll make it on my own time. And then this, well, is this just going to be a pointer? I guess I should let him define it first.
The hero as well. So here we go. Let's go ahead and get that in there. We have draw bitmap, and it is going to take some stuff. We don't actually know what it's going to take yet. We'll find out when we actually go to type it. So here's our draw rectangle call. And our draw rectangle call and our draw bitmap call are actually quite similar. They both have sort of a similar sort of thing going on here, right? Excuse me. But now what we have to do is we actually have to work on this blit to the point where we can actually do something of similar quality to our draw rectangle. Because remember, when we did our draw rectangle call handled passing coordinates off the screen and all sorts of other stuff. So we kind of need something a little more industrial strength than what we had here. Although at first we could just use exactly what we have here and assume that we always pass correct coordinates that are never actually going to be off the left or top part of the screen. So yeah, so let's start off. I guess let's start off simple and just do that. So let's start off by saying we have a draw bitmap call. We're going to pass an x and a y to it that we want to actually use. That's what we were passing. We were using reals. So let's go ahead and use reals. We're going to pass floating point values for their x and the y. And then we're going to pass a loaded bitmap, and we want to be able to basically, you know, have it show this loaded bitmap at that location. So it's going to take this loaded bitmap. It's going to show it at that location. We're going to need that buffer, obviously, because we need to actually draw that in there. And then we'll just assume that
Nope, I have to make the change now. It's bugging me too much. Bit_map becomes bitmap. All one word. There we go.
X and Y now have to be valid at the moment, and will crash if they aren't, and then we can go ahead and modify our routine to be more robust in a second after we get everything working. So we have our bitmap now, and so we don't need backdrop anymore, and backdrop here becomes bitmap, basically, right? Bitmap, 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 like that. And I guess most of this code just kind of works, except we now have a starting x and a starting y. So basically we need to do this sort of code that we did before, where we do a rounding operation to figure out what the actual x and y are for the...
All right. So this is going to be some offsets here, but first of all, let's get rid of these references to frame buffer. Just use buffer. Oh no, we've got x and y being shadowed in there. Whatever. I'll figure it out. And then instead of backdrop, we have bitmap. Well, now it's not giving me an error with that typing issue or whatever that was, but moving on.
So we're basically going to have the same sort of thing that we had before, where we pass in real values, but now we have to sort of round them to be more specific, to be integers that we can actually use to specify a particular pixel, not something in between pixels. All right, so then we can go ahead and do this.
Yeah, I don't know how I'm going to want this to work out, but we'll just say that these are fx and fy.
This check is kind of meaningless now because since we're allowing you to move around, that's not going to actually work. In fact, I guess what we could actually account for just that movement here by saying that the blit width, it starts out being the bitmap width and height, but if the blit width is greater, if basically the amount that we're blitting is greater than the screen width, right? What we actually want to do is say that if the x plus the blit width is greater than the screen width, then we need to go ahead and adjust that blit width to be excuse me, to sort of end there. It's sort of a min and max x, if you will. In fact, I guess we could, you know what, we could do this very similar to how we did, now that I think about it. We could just use the same basic code as we used for our rectangle, right? There's really no reason we couldn't. So let's actually just start with this code, in fact, now that I think about it, right? Because we know that we have an x, y, and we have a min and max x for x and y because the min and the max are determined by whatever this bitmap is, right? So we could really just use this code almost exactly as it is, right in here. I could just start with this. So push that down a little bit and say, all right, we start with this code. We go ahead and say we have the min x, the min y, and those are equal to the rounded versions of that sort of real x and real y that we start at. And then the max x is basically just that real x plus whatever the bitmap width is, right? That's going to be the other end of our rectangle, right? Because we know that we're still filling a rectangle on the screen. We're just filling it with specific color values instead of one color value, right? And so we can basically construct the same rectangle, do the same clipping that we were doing, and then fill it. Now we have to pay some more attention to the code that happens in here, but for the most part, that'll work. So,
well, we see where we're going with this code. We're just going to start drawing bitmaps out. I kind of wanted to get to the point where we'd have that triumphant first draw of the hero on the screen, but I think I'm going to call it here because I'm already over where I thought I was going to be by this point. But yeah, I'll just go ahead and rip this rectangle code. What was that? Draw rectangle. And then draw bitmap. So I think you just shove that down and then drop this in. And yeah, because this is not going to be super exciting. I mean, it will be once we actually have the hero being drawn, but that's how we'll start off tomorrow's stream, whenever that is. Definitely not this late. All right. Thanks for hanging out with me, and I'll see you tomorrow.